So let's talk about lipid functions. We're going to talk about the functions of lipids in the body, why we need the right balance of omega-3 and omega-6 fatty acids, how fatty acids are used to provide energy, and how fat is stored and how it is retrieved from storage. The benefits of lipids and fats is we talked a little bit before that they provide texture, flavor, and aroma to foods. We know now that phospholipids and cholesterol are in the membranes and starting materials for other molecules. Lipids and fats help us absorb and transport fat-soluble vitamins throughout the body. They're actually lightweight, even though we don't think of that. If you have few of them, they are, and are used for long-term storage of energy. And they really provide insulation, cushion, and lubricant for all different types of organs and cells in our body. Here, we want to talk about the storage of excess energy as adipose tissue. So the cells that make up our adipose tissue or fat tissue enlarge when we gain weight so that they can store more triglycerides, and they shrink when the amount of stored triglyceride decreases. So in this bottom picture here, the amount and location of adipose tissue affects our body size and shape. And when people have liposuction to slim their hips, the surgeon is actually vacuuming out fat cells from the adipose tissue in that region. When you look at this picture over here, adipose tissue cells contain large droplets of triglyceride that push the other cell components to the perimeter of the cell. And as weight is gained, the triglyceride droplets enlarge. So you can see here the large triglyceride droplet, and then here it shows the nucleus and cytoplasm of the periphery of the cell. So in this picture, there's lots of large triglyceride droplets. Eicosanoids, had to say that a couple times, eicosanoids are the essential fatty acid. The omega-3s and the omega-6s are used to make hormone-like substances called eicosanoids. And eicosanoids help regulate blood clotting, blood pressure, immune function, and that's why omega-3s and omega-6s are very important besides a lot of other reasons. Fat is used as an energy source. It's more of a storage form of energy source. And, you know, we saw with carbohydrates, how carbohydrates were metabolized. This is the metabolism of fat in this picture. And here we see that the triglycerides are broken down to fatty acids and a small amount of glycerol. Here we see the fatty acid, and then it's going in to be through beta oxidation. It splits the fatty acids into 2 carbon units and releases some high energy electrons. Those are those purple balls there. The fatty acids provide most of the energy stored in a triglyceride model, and fatty acids are transported into the mitochondria, where in the presence of oxygen, they're broken down to form acetyl-CoA, which is further metabolized to generate an ATP, which we know is the energy for the cell. The glycerol molecules, which contain 3 carbon atoms, can also be used to generate ATP. So we saw the first step of this process too. If oxygen and enough carbohydrate are available, the acetyl-CoA enters the citric acid cycle, releasing 2 molecules of carbon dioxide here, and more energy molecules, more ATP here. And in the final steps of aerobic metabolism, the high energy electrons, those purple balls there, are released through beta oxidation in the citric acid cycle, combining with oxygen and hydrogen to form water. And here we can see a lot of ATP is released there, and that's how fat is generated as an energy source. So feasting or fasting, when we eat more than we need, excess energy has to be stored, and it's stored as triglycerides. When we don't eat enough, triglycerides in adipose tissue are broken down, releasing fatty acids, which can be used to provide energy. So this is the process of feasting. When excess energy is consumed, it's stored as triglycerides in adipose tissue. We see the excess chylomicrons and the VLDLs. They're stored as triglycerides in our fat cells. And when no food has been eaten for a long time, not just a little while, triglycerides from adipose tissue are broken down, releasing fatty acids as an energy source. So say we run out of glucose and we need them, but if we have plenty of glucose and plenty of food, we really don't ever break down these triglycerides or adipose tissue until we create a different balance there. So moving on to lipids in health and disease. So we normally associate lipids with heart disease. So more than 80 million people in the U.S. suffer from cardiovascular disease, which is considered heart disease. It's the #1 cause of death in the United States, and atherosclerosis is called hardening of the arteries. And what you really want to know is atherosclerosis is a type of cardiovascular disease that involves the buildup of fat material in the artery walls. And we've linked dietary patterns that tend to be higher in cholesterol and saturated fat and trans fats, and low in the good fats, the unsaturated fats, and low in fiber, to the development of this disease. So here what we can see is how atherosclerosis develops. The inflammation that occurs in response to an injury of the artery wall precipitates the development of atherosclerotic plaque, and this buildup of the plaque can eventually lead to a heart attack or stroke. So here we see a normal artery. This wall is healthy. It's lined with a layer of epithelial cells that are surrounded by smooth muscle. Here we start to see damage to the lining of the artery wall, and it causes inflammation and begins the process of plaque formation. And this injury attracts white blood cells inside it, and we can see the inflammation. At 3, here we start to see the plaque buildup inside the artery wall. The macrophages fill up with LDL cholesterol and transforms into a different type of cell, and the accumulation of cholesterol and proteins form a plaque. Here, for the plaque begins to get worse because we haven't changed our diet, and we continue to have this cholesterol building up, or it also could be genetic, that our liver is producing too much and we just can't process it. So this causes the artery to narrow and lose its elasticity, and then this plaque can rupture, and as the inflammation continues, and blood clots can form around it, and it can completely block the artery at that spot, or break loose and block an artery elsewhere, and this can then, you see here, lead to a heart attack. If the blood flow of the artery is blocked, a heart attack results, and the heart muscle cells are cut off from their blood supply and die, causing pain and reducing the heart's ability to pump blood. So if blood flow to the brain is interrupted, a stroke results, and brain cells are cut off from their blood supply and die. Risk factors for heart disease are diabetes, high blood pressure, obesity, high blood cholesterol. Men over 45, women over 55. Men are at a greater risk earlier in life. Genetics, some people are genetically predisposed. Lifestyle factors including smoking, lack of exercise, and a poor diet. Diet and heart disease risk. We know that a high salt or sodium intake and increased intake of saturated fats, trans fats, and high red meat intake increase our risk. What decreases our risk is high fiber diets and consuming foods, more healthful foods, and higher in omega-3s, fishes, nuts, whole grains, fruits, and vegetables. A decrease in our LDL and an increase in our HDL. So we know LDL is the bad cholesterol. We want to increase our HDL, that's the good cholesterol. So how do we do that? We decrease our dietary intake of trans fats, saturated fats, and cholesterol. We increase our dietary intake of polyunsaturated fats and monounsaturated fats. We quit smoking, we exercise, and we improve our social relationships, decrease our stress levels. Can eating fiber help us reduce blood cholesterol? Well, we've learned that diets high in soluble fiber can reduce blood cholesterol levels. The fiber traps bile in the small intestine and does not allow for the bile to be reabsorbed and recycled. And then the liver is then forced to pull cholesterol from the blood to make new bile. Therefore, it's not floating around in there, causing that plaque buildup. Mediterranean diet was always in the news, and this is, eating meats and sweets less often. We go from the top of the pyramid to the bottom, and we can see all those healthful dietary patterns that we've been talking about all along. Moderate portions, more fish and seafood, increasing fruits, vegetables, whole grains, healthy oils, and being physically active. Cancer is the second leading cause of death. We find that populations consuming high amounts of fruits and vegetables have lower risks of cancer versus populations that don't. Trans fatty acids increases your risk of breast cancer, and we know that diets high in omega-3 from fish and really any omega-3 help reduce our risk of breast cancer, ovary, colon, and upper digestive and respiratory tracts. What about dietary fats and obesity? Well, we know that fat has 9 calories per gram. Carbohydrates and proteins have 4 calories per gram, and fat is very efficiently stored. So excess dietary fat consumption does contribute to weight gain and obesity, and we know that it has more calories per gram than carbs and fat. And despite the fact that fat is fattening, the fat content of the U.S. diet is unlikely to be the sole reason for the high rates of obesity in the United States. Weight gain, and we're going to talk a lot about this throughout this, occurs when energy intake exceeds energy expenditure, regardless of whether extra energy comes from fat, carbs, or protein. And the increasing obesity in the United States and worldwide is likely due to a general increase in too many calories versus too many calories in versus too many calories out.